Hi, my name is Carlos.
And my name is Omar.
And this is Jackass. Hello, for understanding with this topic, we need to know the difference between a continuous and a discontinuous function. A continuous function, it's a function that has nothing on its way that stops it from being continuous. And a discontinuous means a function that has a hole or a jump or a gap or whatever that makes it not follow its own track. So we're going to cover essential discontinuities. In this example, we have a piecewise function made of a linear function and a parabola function. In this case, the right linear function approaches infinitely, never touches, but only approaches infinitely the y equals 2 at x equals 1. And the left parabola approaches infinitely the x equals 1, y equals 1. Because these two have different y's, at the moment they are on the x-axis at 1, they don't have an exact limit because they are different. So in the next, my friends are going to explain the two different types of essential discontinuities that are on math.
This is an example of an infinite essential discontinuity because we have two functions which have a vertical asymptote at x equals 0, and they never touch it.
This is a function. This function is a piecewise function, and it has an essential discontinuity. The essential discontinuity appears when the approach or the limit appears here, but has different values in the function, which is a jump essential discontinuity.
Okay, now let's look at an essential discontinuity in some functions, like this one here. We have x to the third power plus x and it's telling us that x is less than or equal to 0. And we also have a function where it says 2x squared plus 1, and the condition is that x is greater than 0. So first of all, we get x equals 0 out to test its first three rules. First of all, we have to state f of 0. And once we state that, we look at the functions to see where that is acceptable. And as we can see here, it's in the first function because we have x is less than or equal to 0. So we replace the x's with 0 and we will get 0. Next we move on to the second rule where we get the limit of x equals 0, as we can see here. And we have to get the positive and negative side of the limit first of all. So let's take a look at the plus. So in the positive one, we have to look where x is greater than 0. So it's in this function here, we replace again the 0 with the x, and 0 to the second power is 0, times 2, 0, plus 1, 1. And in the negative 0, the limit, we check the condition, it's x is less than or equal to 0, so we will replace 0 in this function, we get 0. Once we've completed those two steps, we can compare that here we don't have a limit because both the answers are different. And to get the third rule, we have to equal these both two rules if the answer is exactly the same. And as we can see here, they are not, so the third rule does not apply. So we can state because there is no limit, but there is a point at f equals 0, there is an essential discontinuity at x equals 0, like we can see here on the graph. We don't have a connection between both functions.
Okay. Here we have another example of an essential function. In this case, we have two numbers in the domain, so we have to equal them to 0 to get the x value. Here, when we have the x value as there, we have to replace it in the original function. And here it is 3 to the square minus 3 minus 6, and 3 to the square minus 9. It's equal to 0 over 0, so it's undefined. And so this step is not correct. In the second step, we have the same. We have to factorize the original function to get the limit, and we have to replace again 5/6. So there's a limit, and yes, there's a limit. So this one is right. Like this, the answer of the first step and the second step are different. The third step is not complete. So, like we have a limit, the function is removable. In this other case, we have that the x is equal to minus 3. So we have to replace it again in the original function, minus 3 to the square minus 3 minus 6, and minus 3 to the square minus 9, which is equal to minus 6 over 0. And so this is not correct. The second step, we have to factorize again the original function, and we have x plus 2 over x plus 3. We have to, again, replace the minus 3 in the x, and it's equal to negative 1 over 0, which means that there's no limit, because if the 0 is at the bottom, there's no limit. So this one is not complete, and it's an essential infinite, because we have to get the positive and negative infinites, and yes.